High-strength materials can be used to create structures that are stronger, lighter, and more efficient than conventional materials, allowing for greater flexibility and innovation in design. For example, high-strength materials are being used in the design of new aircraft and spacecraft, allowing for the creation of lighter and more fuel-efficient vehicles that can carry more cargo or passengers. High-strength materials are also being used in the design of new buildings and bridges, allowing for the creation of structures that can withstand extreme weather conditions and seismic activity. The use of high-strength materials in design and engineering also has the potential to improve safety and reduce the risk of failure. High-strength materials can be used to create structures that are less prone to fatigue and corrosion, reducing the risk of catastrophic failure over time. However, the use of high-strength materials in design and engineering also presents challenges and risks. For example, the use of high-strength materials can require specialized skills and knowledge, which may not be widely available. It is important for designers and engineers to have a thorough understanding of the properties and behavior of these materials to ensure their safe and effective use. In addition, the use of high-strength materials can also be more expensive than conventional materials, which may limit their use in certain applications. It is important for manufacturers and designers to balance the benefits of high-strength materials against their costs and practical considerations. The development of high-strength materials has also had significant impacts on the field of renewable energy. High-strength materials are being used to create more efficient and durable wind turbines and solar panels, allowing for the creation of renewable energy systems that can generate electricity more efficiently and reliably. High-strength materials are also being used to create more efficient and durable energy storage systems, such as batteries and fuel cells. These materials can help to improve the efficiency and reliability of renewable energy systems, making them more viable alternatives to traditional fossil fuel-based energy sources. The use of high-strength materials in renewable energy systems also has the potential to help address some of the most pressing environmental challenges of our time, such as climate change and air pollution. By reducing the reliance on fossil fuels, renewable energy systems can help to reduce greenhouse gas emissions and improve air quality. However, the use of high-strength materials in renewable energy systems also presents challenges and risks. For example, the production of high-strength materials can be energy-intensive and require the use of hazardous chemicals, which can have negative environmental impacts. It is important for manufacturers and designers to adopt responsible and sustainable production practices to minimize these risks and ensure the safe and environmentally responsible use of these materials. In addition, the cost of high-strength materials can be a barrier to the widespread adoption of renewable energy systems, particularly in developing countries or regions with limited resources. It is important for manufacturers and designers to continue to innovate and find ways to reduce the cost of these materials to make renewable energy systems more accessible and affordable. The development of high-strength materials has also had significant impacts on the field of medicine and healthcare. High-strength materials are being used to create more durable and effective medical implants, such as artificial joints, dental implants, and heart valves. High-strength materials can also be used to create medical devices and diagnostic tools that are more accurate and effective than conventional materials. For example, high-strength materials are being used to create microelectromechanical systems, MEMS, for use in medical sensors and diagnostic devices.